All right, in this lesson, we're going to talk about side-angle-side congruence theorem. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. An included angle, it means between the sides. So it's got to be between the congruent sides. So here we have two triangles. So if AB is congruent to DE, AC is congruent to DF, and angle A is congruent to angle F, then triangle ABC is congruent to triangle DEF. And this is true because triangles only go together one way. If you have three segments that can create a triangle, they will go together exactly one way. So if I have like here in my example, if I were to take out this side, I would still have only the ability to put a side in that size. I couldn't put one in larger because it wouldn't fit, wouldn't make a triangle. And I couldn't put in one smaller because then that would change the angle. So triangles go together exactly one way, which is why we use them in construction, because they can't be pushed out of, they can be broken, but they can't be pushed out of shape. So let's build a theorem and use side angle side and see how it helps us. Because prior to this moment, we needed all three sides and all three angles to be congruent in two triangles to have congruent triangles. Now we need two sides and the included angle, which means the angle between the congruent sides. So let's start off. We've got a congruent side that's given. That's right here. We've got them parallel, which is given. So we're going to use that first. Then we're going to say, so that gives us our first side. Angle BAC is congruent to angle, BCA. Angle BCA is congruent to angle DAC. Let's get our colors straight. And how do we know that's true? Well, we got two lines, two parallel lines cut by a transversal. So by alternate interior angles, those angles are congruent. So this is congruent to this. AC is congruent to CA. That's our reflexive property. And then we have a side, we have an angle, we have another side. The angle is between the two sides, so we have congruent triangles by side, angle, side. It keeps it really simple for us. Well, let's keep going and let's do it again. Let's see what else we can do. Well, B, right here is the midpoint of AD. So that's given. AB and BD are congruent. That's a definition of a midpoint, because a midpoint is the middle point, so the segments on either side of it have to be congruent. All right, and that's all the further we can go with that. That is our side. Triangle ABC and angle DBC are right angles. That was given to us up here, so we're going to use that. So angle ABC is congruent to angle DBC because of the right angle congruence theorem that says all right angles are congruent to all other right angles. So we know that these two guys are congruent. So we have an angle. So we have a side, we have an angle. So now we need another side. And we need this side up here so that the angle is between the two sides. So BC is congruent to side BC. Why? Because of the reflexive property. Because no matter which triangle it is, it's going to be the same length. This is our second side, so by side, angle, side, we have two congruent triangles. All right. Let's take a look at another example and see if we can't show that triangle MRS and triangle MPQ are congruent. So we know that segment QS and segment RP pass through the center of the circle M. So M is the center of the circle, so on each side of of M is a radius. SQ is a diameter. RP is a diameter. If it's cut in half, then SM is going to be congruent to MQ, right? Because of the radius of a circle. RM and MP are going to be congruent for the same reason, because M is going to be the midpoint. So we have two sides congruent. So we need an angle, and the angle we need is this guy here in the middle. Well, angle SMR is congruent to angle, sorry, let's name it this way, QMP. And how do we know that? Because they're vertical angles. They're across the X from each other. So triangle MRS is congruent to triangle MPQ. Why? Because of side, angle, side. Side, then an angle, then a side. The angle is between the sides. We can use it. We are legal. So let's look at this. What can we conclude about angle PTS right here? Triangle PTS, sorry. And triangle RTQ. We can conclude the triangle PTS is congruent to triangle RTQ by side, angle, side. Well, how do we know? Well, RT, that's right, the other way. PT is congruent to RT. ST is congruent to QT, also given. So it gives us side and side, side and side. So this is the angle we need. So angle PTS we know is congruent to angle RTQ. Why? Because they're vertical angles. So we can conclude that triangle PTS is congruent to triangle RTQ by side angle side. And then one more proof, and we'll just get rid of this extra nonsense from my earlier copy and paste error. All right, so now we're going to deal with a square and some midpoints in that square. So SV and VU are congruent, and that's given. RT and SU are perpendicular, that's given. So VR is congruent to VR. Well, that's our reflexive property showing up once again. So that's going to be congruent to itself. So definition of perpendicular lines. So if two lines are perpendicular to each other, they meet to form right angles. So angle SVR and angle UVR are right angles. And why did I pick them? Because they're in the triangles I want to prove. That helps me out, so I'm going to take advantage of my own personal discretion and make it easier. Right angle congruence theorem. What does right angle congruence theorem tell me? It tells me that all right angles are congruent to all other right angles. So we have angle SVR is congruent to angle UVR. So here we have a side, here we have a side, here we have an angle. The angle is between the sides. So we have two triangles congruent by side angle side congruence theorem, and we are done.